So in this particular session, we are going to look at image analysis. Before we get into the topic, let me give you an introduction or how important something like this, because the code looks deceivingly simple. So I need to highlight the importance of what we are going to do. So back in 2006, while I was starting my career in Microsoft, we've been given a task by one of the university professors. So the idea is just print something related to the image, given an image. So the input to the program is an image, and just give a description about it. For example, a laptop sitting on a table. You're giving an image of a laptop sitting in a table, and the program should print laptop and table, or laptop on the table, or something like that, or a candle on a table, or some kind of description about an image. Sounds very simple, straightforward, but we tried a lot of things those days in the early 2000s, probably late 2010s. We couldn't do it. By then, the technology, the neural network, deep learning was not this good, and we couldn't achieve that particular task that time. But fast forwarding some 20 years or 15 years, this is as good as 2 or 3 lines of code. Although we are going to call the Microsoft AI services, we can run this thing locally as well using LM Studio, like we have seen. There are so many image to text models out there you can run locally. So what we've been seeing so far and what we are going to do is very, very important from the technology perspective. It was not something we could have done a couple of years back. Without further introduction, let's get into the program. So computer vision. So just like the name says, it is an AI service which exactly behaves like a human vision, looking at things and figuring out objects, text, and things like that. Just like our eye, this particular service behaves. So we give mostly images to it, to the service, and we get JSON output describing the image and figuring out things inside the image, converting text and things like that. There are few overlapping services in Azure which test the computer vision, but for the time being, we are going to consider this one particular service as one particular object, because we will be using the same Python library or any other programming language, because it's particular REST API service we will be creating in Azure and using it. So what we are going to do? So we are going to go into Azure, then we are going to create the computer vision service. And next, what we are going to do is we are going to get the endpoint and the key, and then we are going to get into our Python code and execute the Python code. And what we will be giving to the Python code? Mostly an image. So we'll be giving an image to the Python code, and what is the Python code is going to give us? A JSON. So it'll be in the form of an object, but we know that it is a REST API behind the scenes calling to this particular service right here and getting the JSON, but we will be seeing this as an object. In some of the cases, we will do a crude print of the JSON or the object we are going to get from the SDK library we are using to call the REST API. So that way, it is pretty standard for all the services we are going to use, creating an endpoint and calling that particular endpoint from an SDK, which calls the REST API internally. So let's get into Azure. If any of you don't have an Azure account, please create it. So you need a credit card for it, and this will be charged only when you call the API. So feel free to create it. If you're simply creating a service, doesn't cost you anything, but when you call the API, that's when you get charged. There are free tier for certain services. In my case, I'm not going to use the free tier. I'll be using the standard tier. But in your case, if free tier is available, feel free to use it. Again, just like any other service, by the time you watch this video, this could be deprecated. I'm giving that warning with every service because it's very rapidly changing field we are watching right now. So being said that, let me go to Azure and create one of these services. I have already existing services, but we'll create another one anyway. So I'm in my Azure portal. This is my Azure account. So I have logged into my Azure. So this is the AI services. I'm going to click on the AI services. As you can see, all my AI services are here. Pretty much this is what we're going to explore throughout this training, one by one, Azure AI services. Right now, we are going to look at computer vision. This is the service we are going to focus in this particular lesson. So what I'm going to do is I'm going to create one of it. So it'll come like this for the creation, and you can select a resource group or create new. Not going to details of what is resource group in Azure. It is very Azure specific stuff. We'll try to reduce our discussion on Azure specific things because we have a lot to cover on the AI side, especially not relating to the AI part of it. For example, resource group is something like that. I'll try to give you an overview in the appendix of the training, but for the time being, we are ignoring such details. So we need a name here. So this is the name I'm giving. So if there is a error, it will normally show it here. Once you type the name, this is okay for the time being. So you need to select a pricing tier. In my case, it is the standard pricing tier. Sometimes you get free, but feel free to select whatever you like. So you need to acknowledge all the terms and conditions, review and create. It is as simple as that. And there is one final creation. So there are a couple of different things here. Azure specific network to further tighten it down. This is the access control and things like that. We'll have a separate session on these things, but for the time being, we are going to simply review and create. So it is initializing the deployment. So you have a status here and it has created. So we can go to the resource. Deployment is complete. So the service has created. So this is the resource we have created, computer vision resource. And this is the most important item in the resource which we need. One is our endpoint. This is our endpoint, which we will be using in the code. And this is going to be the key. So you can copy the key right here and you can use it in your code. So there is this thing called Vision Studio. Most of the AI resource in Azure has a studio associated with it. So the idea of studio is mostly visually inspecting most of the services without writing any code at all. Very useful feature if you are new to coding and things like that. Before you start coding, it's always good to get a feel of what a service is, visually get a feel of what the service is. We will be exploring studios, AI studios. Different studios are there for speech, text, vision. Most of the services these days coming with studio. So we'll be exploring it for the time being. We'll be looking and focusing on code. So basically studio doesn't do any magic. It is calling this service which we have created, calling this particular endpoint from a different client, a very user-friendly client. Basically, Studio is nothing but our Python code itself with more bells and whistles and UI and things like that. So that is what Vision Studio is. It'll automatically generate a lot of code and shows us a couple of things in a easily viewable format. So I'm back to the Azure AI services and I want to view all my computer vision. So this is where you view all your computer vision services. This is the one we have just created and this is the one which I've created before. And this is part of my free tier. So I won't be paying for this particular tier. Only one of that you can create. I have created it before and I'll be using this particular service instead of the one we have just created. But feel free to take any of the endpoint and key, but I recommend this free tier for you. If you're testing something out, that's the purpose of it. So if you want to have a look at the endpoint, this is the endpoint we'll be using in our code. Before we get into the code, I'll give you a quick overview of what are the items we're going to look. So these are the different samples we'll be looking. And inside that, there is one sample which will not work, which is the celebrity detection. So celebrity detection is a gated service. We need special permission to obtain that service. We have not got the permission, although I applied for it. For training purposes, Microsoft doesn't allow celebrity detection service. That's the explanation they have given me. So except this celebrity detection service, we will be seeing the output of every one of it. For the celebrity detection also, we will be running the sample, but we will be seeing the error saying that we need to request. The reason I'm showing that is there are a couple of gated services. You may see that error, and that means that you need to request permission with Microsoft, especially if you are working in a big corporate and if you have a big business impact, you may have to explain it to Microsoft and get that gate opened for you. It is called gate in Microsoft terminology. So there is a team working in Microsoft to open that gate provided your business impact and use case. So why that is done, there is a lot of crime associated with this AI services to prohibit and control that crime. Microsoft has done that. In fact, almost all the AI providers has done that gating and censoring and things like that. So it is part of that. To be honest, I don't know how this can be misused, but I'm sure there are misuse cases. That's the reason why they have gated it out. So being said that, the other samples are all good. So we'll be seeing one by one. First is image analysis. So these are the imports which we need in the code. Almost all the sample just need this one pip install. In fact, anything is having issue. Any of this import is having issue. What you can just do is simply copy this and go to Google and search for that particular pip install. As you can see, it directly goes here and you can copy this thing and do your pip install. So if you don't know what is pip install, watch my previous training on Python. So this is not a Python training. If you're new to pip, it means that you have a lot to learn in Python because we have been doing pip throughout that training. Or you can search for what is pip install. It's just a command you execute in your command prompt. So that's all about the library. If any of the library is missing, that's what you need to do. Just copy it and put it in your browser and do a pip install and get the URL just like I did. Just like any other examples we are seeing in this training, you can do it in virtual environment or Jupyter notebooks. Doesn't matter. These are the things you need for this particular sample to work. So this try catch is not needed. Let me remove it. The sample will work even if it is there. Initially it was being read from an environment variable. That's why the try catch was there. So I'm just removing the try catch. Straightforward hard-coded endpoint. And this is a client we are creating. So the client name is this particular object name or class name. So if you want to know more information about it, again, copy and paste it here. So you will get the image analysis. AI services, vision, the documentation. So this is how you get more information about it. So there's a C# sample. The sample we are looking is the Python. So if you want the Python sample, you can click here. You'll get the Python sample. So the pip install is mentioned here. So we are looking at the 3.2 version of the image analysis. So the names are slightly different. So that's why it is computer vision client. In our code, it is image analysis client. So let's have a look at 4. In our code, it should be 4. I'm going to click on Python. Yes, this looks more like it. And this is what we are creating, image analysis client. Pretty much this code is copy pasted here in our example. So as you can see, there is multiple ways to call the API. Feel free to try all these things out. But in our case, we are going to use the Python we're having. And this is how you access it from a production application calling the REST API. So feel free to explore this particular documentation if you're developing an application, so you will understand all the capabilities of this particular object. We'll not be discussing each and every properties of the object, but feel free to look at the documentation if you're planning to use this particular object. We'll be looking at Vision Studio, but for the time being, we'll be sticking on to our Python. So that's what the object is about. the object we are creating, the client object. Now, this is the URL of the image. Let's have a quick look at the object. So we are going to look at this particular image using computer vision. It's an image of Taj Mahal. Let's see what it's going to tell us about this image. Now, what are the things we are interested in the image? We are interested in tags, objects, any text, smart crops. I'll just explain what smart crop is. People, if there is any people, we are interested in that. So we'll have a look at the output of this whole thing. So I have commented out a couple of things just to make things simple and straightforward. Certain images has some difficulties with some of the options, so I have commented that out. Depends on the image. Feel free to uncomment and experiment with a lot of images if you're interested. But for the time being, we are continuing with these options. These are the things we are expecting from the API, from the service, to tell us about the object. After that, the code is straightforward. We are calling the API analyzed from URL. So we are giving the URL. And what are the things we need to analyze, which is what we are giving here. As you can see, it is an array or a list we are giving, the visual features. And we are giving some smart crop aspect ratios. I'll explain what this crop is. So these are some of the options which the API takes. Feel free to look at the documentation which we have seen for any kind of explanation. Some of the things we need to try out, but mostly these things we take the default unless we want to do something very specific. Language English, gender neutral caption true. So different knobs and tweaks and tuning for the model behind the scenes. That's what this is all about. Now, a little bit about the crop thingy, which I discussed. The idea is just that we want the model to find out what is the most important thing inside the image. So let's have a quick look at the image. For example, in this particular image, the most important thing is this particular part of the image, the building itself, the mosque itself. It is the Taj Mahal. That's the most important part of the image. So the idea is asking the model, hey model, if I'm going to show this image in a thumbnail or in a shorter fashion, which part is the most important part? How do you crop the image such that I get the most important part? Does it crop here? For example, there is a human here. Is it a good idea to crop here? How about cropping here? How about cropping here? So that's the cropping or smart cropping is all about. It's a very useful service when you have a image gallery kind of thing where you want to show a crop of the image so that it comes correctly. So that is the smart crop is all about. So we won't be verifying the smart crop. We'll just verify if we are getting the output, and then we are trying to print out the result like this. We'll not pay much attention to this. What we are going to do is we are just going to put a breakpoint here and analyze the result object in the watch window like we always do. The reason is that printing is good, but watching, you will see the entire object, and if there is anything interesting in that object, you will be able to figure out and use it later. That's why I prefer that way of explaining and analyzing the result. So without further introduction, let's go ahead and run it. So run start debugging. I have a breakpoint at line number 48. So if everything is good, we'll get a result. I had another breakpoint. Let me continue from that breakpoint. Looks like we got the result here. Let me close all the unnecessary things. And we have the result inside the watch. If it is not there for you, you can drag and drop it here. So this is the result we got from the API. As you can see, everything with underscore we are going to ignore. Everything without the underscore. So this is having an underscore, we are going to ignore it. So what are the things we are having? So we have special variables, function variables. Those are things which is with all the object we are going to ignore. Caption equal to none, dense caption equal to none. That's because we have given this things commented out. That's why we didn't get anything. Metadata. So this is a little bit of information about the image itself. It has height and width. And this is one of the important thing, model version. So this model version is the actual model, the AI model, which is analyzing the image. Normally it is higher the better, but this is the model version, it's a returning. Depends on the model version, the output can change here and there. Depends on the model. So the next thing it has returned is the object. So object, this line number 28. object. So let's see what we got in the object. So again, within that object, we are going to ignore the underscore things, and special and function variables we are going to ignore because that's there with all the object. It's not important to us. So what we have is a list, and inside the list we have just one element. Let me expand this a little bit so that it'll be easier to view. Again, same principle. We are ignoring the special functions and underscore. We are going to click on bounding box. So there's a bounding box of the object within the image. So this is the subset of the object it is finding. What is a tag? Tag is, it's saying that it's a castle. Pretty accurate with a confidence level of 0.507. It's not too high confident, but reasonably correct within the knowledge of the model. Model is saying that what we are giving is a castle. It doesn't know about Taj Mahal or anything like that. That's why it's saying it's a castle. That way, the model is pretty generic, but there is a castle within the image, within this bounding box right here. As you can see, it is the X coordinate and Y coordinate and length and breadth of the castle within the image. So the object, one of the object it has found is a castle within the image. The next is people. People, again, it's a list. So many people it is finding. So many, 39 objects. In fact, 40 objects. The count is starting from 0. So 40 people it has found. Where is 40 people inside that image? Even I don't know. So we need to analyze this. And it is saying with pretty high confidence. And the bounding box is this. So this is the bounding box. If you look at this, we can see that it's pretty close, all these people. So if you look at the image, so let's go to the image again. So if you look at the image, there are so many people here. And I think it is counting all of these small people, all the small objects they are counting as people because it is clearly identifying humans. The model is very sensitive to humans. Probably if we zoom and analyze the image, we may get 40 people, but for the time being, I have to trust the model. If you want to test it, give a different image which has more recognizable number of people, but this image is not a good example for that. But the model is saying that there is 40 people. I don't have anything to counter say to the model. So people, number of people it has counted. Read, so it's all about any text within the image. There is no text within the image. Smart crop. Smart crop is, like I mentioned, any important part of the image within the aspect ratio. So this is the aspect ratio we are giving. So it has found 2. Again, bounding box. So the image is most important in this particular part. Again, it has given another one here, another important part. So in this kind of scenarios, the AI Studio is very useful to see where the cropping happens and you can evaluate. Sometimes the model is little off, but sometimes it is accurate. Most of the time it is accurate. Most of the result within the model has a confidence level associated with it. So pay attention to it. If the confidence level is pretty low, which means that the model is not sure about what it is talking about. Depends on that, you can ignore the result or not. So we have seen almost all these things. One of the things we are yet to see is the tags. So this is the tags. Let's see what are the tags it's giving. Again, we are ignoring these two things and going to the list directly. So many tags it is giving. Let's see one by one. So it's saying that it's a building, sky, outdoor, dome, landmark. Looks like it is able to figure out. So there is a landmark with high confidence. The confidence level is pretty high. So it may be knowing that it is Taj Mahal. Not sure because it is indeed a landmark. Reflecting pool. Interesting. Yeah, it is indeed a reflecting pool. Just like a human, it is finding out different tags about the image. Historic site. Indeed, I think it is definitely able to figure out it is Taj Mahal, but for some reason it's not giving that word. Place of worship, mosque, grass, ground, all 100% accurate. It would have been nice if it had given the name Taj Mahal, but it is indirectly giving all the information about it without the name. Very interesting. So we have got 16, 17 tags and almost all of them are right on spot. I don't know what this is. I don't even know how to pronounce it. Probably you can search in Google if you're interested, but it doesn't really matter. I would ask you to test some other images as well rather than sticking with the image we have seen. But otherwise, that's all about it. Image analysis. These are the things we are getting from the image. So some of the things we have seen, we are printing it out. I'm not going into the details of that print. I would like to access the image in the watch window, but if you need code for printing, it is right here. Feel free to have it. Otherwise, we have seen almost everything inside that object we got from the API. So before we wind up, one of the things I would like to do is to uncomment this options right here just to see how it behaves. I'm going to uncomment. Now we should get this also in the output. I'm going to do an execution, start debugging. The breakpoint is exactly at the same place as we have seen before. No change there. As you can see, this time, along with the other things, we got a caption and the dense captions. So we got a caption text right here, a large white building and towers and a pool of water with Taj Mahal. It is clearly able to recognize the object correctly. So we were right about it. It has understood that it is Taj Mahal with a confidence level of 0.7, which is very high. Confidence level is nothing but a probability. Dense caption, what is the dense caption? Let's see. There are a couple of different dense captions are there. So all these are different captions for that image. All are pretty accurate. So we got total 10 dense captions. So it is pretty accurate with its explanation of the image. Feel free to try some other images. You should get some different results and accuracy levels and things like that. Pay attention to the confidence level. If the confidence level is less, it means that it is not sure about what it is talking about. So we have seen image analysis. We have seen how to interpret an image using AI services. Like I mentioned, this is not specific to Azure. This kind of services are available in AWS, GCP, third-party providers, and like I said, you can run locally as well. Let's get into more of programs like this in the image analysis.